I'll just give a minute for a few more people to join and then I'll start the presentation. Good evening everyone, and thank you very much for joining today's webinar. This is to celebrate obviously International Women in Engineering Day. Just hopefully everyone can hear me and everyone can see the slides. Just a quick overview, this is brought obviously from the IET, the Young Professionals Group. And today with us we have Marta, Ferran-Marques and Jane Atkinson, CBE. As you can see from on the slides, Marta is a material engineer at Sensor Coating Systems, as well as a crew scientist and media officer for WoMars. And Jane Atkinson is CBE, is a chartered chemical engineer and the Executive Director of Engineering and Automation at Bilfinger UK. So first off, I'd like to just welcome them both and welcome everyone. Thanks very much for joining. And I would like to pass over to Marta to start her slides.
Okay, so I'm going to share my, oh, it says I can't share my screen.
Oh.
Because you're sharing yours, I think.
Apologies.
It's okay.
How do I unshare? Stop share.
Right.
Hopefully.
Yeah, now I can.
Perfect. Apologies.
That's okay. Can you see my screen?
Yeah, perfect.
Okay. Yeah, so welcome everyone to the Women in Engineering webinar. I am Marta Ferran-Marques, and I am very glad to be here today and to represent women in engineering, because as you know, we are still the minority, and I believe we should push a bit the numbers and tell the young girls that they can also become engineers one day. So today I'm just gonna go through my story a little bit, and I'm gonna explain just some technical things and some funny things, so a bit of everything. I'm not going to go very much into detail, but yeah, so well, let's go. So yeah, first on my story is I started studying nanoscience and nanotechnology for the bachelor, and I studied it at the Autonomous University of Barcelona. So I have to say, at the very beginning, I wanted to study architecture, but there was a big financial crisis in Spain, and my mom and my friends and everyone convinced me to not study architecture anymore, but go for something else. So then at my little hometown called Reus, close to Barcelona, they did an exhibition about nanoscience and nanotechnology. So I was there and I saw like little robots and very fancy stuff that just sparked my interest. And I said, okay, I want to really study this. So apart from that, the thing that also made me make this decision, it was because it was Barcelona was the only place teaching nanotechnology in Spain, and I was going to be the fourth graduated generation in Spain. So that really sparked my interest. So what's nanotechnology? What's nanoscience? Well, so nano, the prefix nano means 10 to the power of -9. So for example, if I say nanograms, that would be 10 to the power of -9 grams, or nanometers. So basically, as you can see, it's very, very small things. We're talking something like DNAs and viruses, so it's very small. So the thing is that nanoparticles have a very big surface to volume ratio. What does this mean? Well, if you think of a nanoparticle, it's very small. So almost all of it is just surface, and there is no volume at all. So that means that they have this like very big surface to volume ratio, and that makes them to have special properties. For example, if you think about gold has like a yellowish color, and it's like very stiff, while if we think of nanoparticles made of gold, they are red and they are flexible. So as you can see, nanotechnology offers a new world, basically, where we can design different things and make the most of it. So basically, if you study nanotechnology, you study a bit of everything. So you do biology, chemistry, physics, and maths. That's what nanotechnology is. So a bit of everything in science. So for my bachelor dissertation, I kind of combined all of this, so biology, chemistry, physics, and maths. And we designed a membrane. So that's actually the membrane. So in red would be the membrane, which is porous. That's why it's like kind of like going up and down. And then this, because it's porous, we could insert a drug, which is what is represented here in green. So basically, the idea of this was, let's say you have a tumor exactly in this finger, let's say. So what you would do would be take this membrane, which is called a nanobot, because it actually acts like a robot, but it's just a very small membrane material, so you wouldn't able to see by eye. So you would take it as you would take pills, and because it was magnetic, I would place here a magnet, I will go directly to your finger. So then it will release slowly the drug, and then because it was biodegradable, it will go itself, and that will be it. So that, of course, would be amazing for medicine. And as I said, it's mixing the properties of a nanomaterial with the application on biology or medicine. So once I finished, my last year of nanotechnology, I did an Erasmus in Le Mans in France. And it was a nice experience. It wasn't my first option because I didn't know French. But it was really good, actually, because, I learned how to cook crepes. I learned how to eat good cheese. And I also learned French. So I think it was a very nice experience, and I encourage everyone to do that. Like, if you really want to know a language, the best thing to do is just go to that country. When I went, I had definitely no clue on any French, but when you're there and you need to ask for a coffee or for water or where is the toilet or just normal stuff, you develop like a fast skill of learning. So it was very nice, and I'm very happy I went there and did it. And I encourage everyone to just go and explore the world and learn as many languages as they can. So once I finished, the bachelor, I studied the master in aerospace materials at Cranfield University. So that's close to Milton Keynes and Bedford in the UK. It's very well-known aerospace university. They only do masters and PhDs, and they also have an airport. Well, they do experiments, so that's very nice. And so maybe you're thinking why you did nanotechnology then aerospace, like what's going on, right? So well, after my bachelor dissertation, I really figured out that I didn't want to continue with biology, but focus more on the physics and the materials part of the nanotechnology. So then by the time I applied to nanotechnology, when I decided I was not doing architecture anymore, my second option was the design of spacecrafts. So although I went into nanotechnology, I still had the feeling I was missing out something, and I somehow wanted to mix both, so nanotechnology but also aerospace. So I thought, why don't I apply the materials that I have learned from nano to the aerospace world? And I thought the only way of doing that was to learn a bit more in aerospace, because by the time I had no idea on anything about aerospace. So I just pointed my career out that way. And yeah, so just if you're thinking what's aerospace materials, what do you do? So just to give you an insight, did you know that the temperature in a gas turbine engine is higher than the melting point of the metal constituting the engine? That's crazy, right? Because then how are we able to fly? If it's higher, then it should melt, and then the whole plane would be like not working at all. We would be in fire as well. So that's because if we look into a gas turbine engine, it's composed of very small components, as you can see here. These are the ones that basically let the air go inside, and these are rotating very, very fast. Some of them are rotating, some are not. So if we take a close look at one of these components or pieces, which are called turbine blades, you can see that they are coated with a white coating, which is called a thermal barrier coating. So the thermal barrier coating, basically, if we go even deeper, here we have like a scanning electron microscope image, basically using nanotechnology. So I'm kind of mixing both. If we take a closer look, we have the thermal barrier coating and then the metal. So what's the thermal barrier coating is acting as an insulator. So although the temperature here is very, very, very high, it decreases that so that once it reaches the metal, it's not so high and the metal does not melt. So that allows us to go to higher and higher temperatures. And we need this because the higher the temperature, the higher the efficiency in the engine. So that's why we need the thermal barrier coating. So that's, for example, an aerospace material, or basically surface engineering, where we modulate the surface of a material to withstand higher temperatures. So as you can see, surface engineering and nanotechnology are helping to increase the temperatures in gas turbines. So once I finished my master, I studied a PhD between Cranfield University and Sensor Coding Systems. So it's an industrial PhD. And I also started working for SCS, or Sensor Coding Systems. So the thing of the industrial PhD, I think it's very good, because although I am working for that company, and when I have time, I do the PhD, which I have just submitted my thesis, so I'm very happy about that. You are for 3 years working, you're gaining working experience, and once you finish, you get your PhD title. So it's very, very convenient, I think. And I encourage, again, people to do that if they are thinking, should I do a PhD, should I not? If you really like the university field and you want to continue the research, you can do a PhD, of course. But if you have the option of doing an industrial one, I think that's the best of the best. So I'm just going to go through what have I done in this PhD. So as I said, we want to increase the engine operating temperatures, right? Why? Well, because as I have said, it increases the efficiency. It also lowers the fuel consumption and it lowers the emissions. So I'm sure you will have seen that there are some airlines that claim lower emission flights, and you may be thinking, why? How do they do that? Well, one of the reasons may be because they have increased the temperature in their engine. But there is a balance, there is a trade-off, right? So if we increase the temperature, we can also reduce the lifetime of components, and ultimately overheating can cause failure. So as you can see, we really need to measure the temperature in the engine and understand if the materials can withstand this temperature or not. The current temperature measurement techniques, maybe you know thermocouples. If you think about a thermocouple, it has lots of wires. So if we put this thermocouple in a turbine engine, which is rotating very fast and it has these very small pieces, of course, this is not viable. So we need something else. We need a new temperature measurement technique. And that's what sensor coding systems and during my PhD, we have developed. So the thermal history technology is based on temperature memory materials, which is a powder. And then what we do is we paint or we coat this material into the component of interest, let's say a turbine blade. Then this turbine blade goes into an engine test and it's operated at very high temperatures. And once it has cooled down, so it's room temperature, comes back to SES and we shine light onto it. So basically what we do is we can correlate the luminescence properties to the past maximum temperature the component has seen. So we end up having this 3D map saying all the temperatures at each point of the blade. So we have lots of coverage. And so here, for example, the red color would indicate higher temperatures and the blue lower temperatures. So it's a unique temperature measurement capability, and my PhD has helped to develop it further and to be capable now of measuring temperatures up to 1600 degrees Celsius. So during the PhD, I co-founded WoMars. So WoMars is an all-female analog astronaut crew. We are 6 girls, each of us with different backgrounds. We have a biologist, we have engineers, we have geologists and an astronomist. And so what we are going to do is we're going to go for 2 weeks at the Mars Desert Research Station in Utah, USA. And there is a station like the one they are planning to build on Mars. So we're gonna spend there 2 weeks doing research and also living as astronauts would live. So that means if we go outside, we need to wear an astronaut suit. We're gonna eat some dehydrated food. If we send messages, there is going to be a delay. So at the same time, apart from, of course, our own research that we are taking and with several companies or universities that they want to test their research there, we are also testing us because we are going to be in isolation, which nowadays it's nothing extraordinary, but well, but also we're going to study how we can react under very stressful situations and basically explore the role of gender in this space exploration, because we are only the 4th all-female crew going to the MDRS, and there have been around 300 crews going there, so very few. So yeah, now WoMars has also become an association. So it's not only that we are just going to that mission and that's it, but we want to expand. We want to continue doing missions. We want to go to schools, to universities, to encourage the young girls to continue following an engineering career, and to tell them that they also can do it. So it's not a men thing anymore. So, well, that's about me. I'm about to, as I said, finish the PhD. And my main goal in my career is to become an astronaut, or at least to help in future space exploration. So I hope one day I can work for ESA, NASA, SpaceX, or whatever. And you know, most of the people say I'm very ambitious. That's too much. Be careful, because maybe you don't achieve it. But I think it's very important we are ambitious, and it's very important that we encourage girls. And I hope today I have shared my willingness to pursue this career, and that you are now that you can now feel the strength of becoming an engineer as well. So yeah, that's it about me. And if you have any questions, I will be very pleased to answer them.
Thank you very much. That was an incredible story. If anyone wants to ask any questions, if you could use the Q&A part of the Zoom, and we can see your questions. So we've got a question here from Alex. It says, surface coating temperatures, how precise are they and how accurate?
Okay. So we have measured the standard deviation, and it's about ±5 degrees on each of this. So they are quite accurate. And the thing is that we can, each of these dots that you have seen, it's just 700 micrometers in diameter. So we can take thousands of points through a component. Yeah.
Has anybody else got any more questions? Obviously, it takes a minute to type these questions, doesn't it? We've got another one, sorry. What are the gender-related metrics to the WoMars mission?
So well, we are the research that we are going to take regarding that we are all women is going to be with the University of Iowa in the States, and they have been studying mental health during the missions. Basically, they've always been, as I said, mixed crews or only men crews. So now it's going to be all female. So they are very interested in how we get along with each other, and if there are any differences between all female or just men and female crews.
Okay, I hope that answers the question. I've got another one here as well. Do you think there is an application for these sensor coatings in any consumer product use?
Well, we can just measure temperatures to anything that gets hot. So we can measure temperatures from 150 degrees more or less to the 1600 degrees Celsius. So yeah, it's a wide temperature range, and if you are interested in knowing how hot your oven gets, we could potentially measure it.
Sounds good. Another question regarding your WoMars mission. Have you all met and worked together in previous?
That's a very nice question, actually. No, we haven't met each other. So I'm gonna just share a bit the story. It's so I just basically uploaded a video on LinkedIn like 2 years ago saying I wanted to become an astronaut, and the video went viral for some reason. I don't know why. So then I had lots of people contacting me that they also wanted to become astronauts, and I met one of the girls that I met was Lauren, and she actually suggested me, why don't we form a crew, an all-female crew, and we end up forming WoMars. So basically, two of the others are two of my friends and two of Lauren's friends. So Lauren has met the two of her friends, and I have met the two of my friends, but they have never met each other. So yeah, it's gonna be, we wanted to meet this summer, but we are not from the same country either. So it's very difficult with the COVID situation. Yeah, it would be nice to meet before the mission, but yeah, it's gonna be interesting.
Is that going to be impacted by COVID? Like obviously the mission?
Yeah, so it has actually been impacted. We should have gone in February, and of course didn't happen. So now it's gonna take place in October, hopefully. But yeah, we'll see. Still don't know. Yeah.
Sounds good. Oh, that was another question like that one. What was the funding situation that you have for WoMars, I presume? Someone's put it sounds expensive, so I can't imagine.
That's nice, yeah. Good question as well. Yeah, so yeah, of course, it's something we got. So you need to send a research proposal, then you get it accepted or not. So we got selected, we can go to our mission, but of course, yes, you need to pay. So basically, there are several companies funding the research just because they want to take with us. For example, there is one that wants to test their drone that works without a GPS system. So that's going to be interesting in Mars, for example, where there is not going to be any GPS system. So there is this. Then there is the same for myself. The people that funded my PhD is the Royal Commission for the Exhibition of 1851 here in the UK. It actually belongs to Princess Anne, and they fund several research projects, normally PhDs, MSCs, and so on. And well, they just realized I was going to do this WoMars mission, and they were very happy to fund my part of the project. And then we also did a couple of crowdfundings. They were very, very satisfactory ones. And yeah, but still, we are still looking for more funding because we don't still have the whole thing. We need to go there. So if you'd like to contribute, you can visit our website, which is just womars.co.uk, and you'll find the crowdfunding link there.
Brilliant. Thanks very much. If you want to pass them details on, I can share them with obviously everyone.
Oh, yeah. Thank you, Georgia. Yeah.
No problem. We've got another question. Would you ever consider becoming an ambassador for the IET, like obviously ourselves here?
Yes. So I have to say, maybe because I'm not from the UK, but I've never. So I've heard sometimes about the IET, but I've never heard about the ambassador program or anything.
Okay.
So yeah, I actually was looking at it today, so I want to have a closer look, and maybe, yeah. Thanks.
We can share that information afterwards as well. Sounds good.
That would be nice.
Yeah, brilliant. if there's any more questions or anyone thinks of any more, we'll do them at the end. And then if we pass over to our next speaker for now.
Okay.
But thank you very much. That was an incredible presentation and very inspirational. So thank you.
Thank you.
Hey.
Yeah. So
Okay, let me see
our second speaker, Jane, if you're ready to go.
Can you see my presentation? Can you hear me?
Yeah. Yeah, all good. All good.
Fine, that's a good start. Well, first of all,
Brilliant.
how inspirational
I'll pass it
was
to you. Thank you very much.
It's okay. I mean, how inspirational was that? I mean, in 10, 15 years time, we can all say we know an astronaut. That's where I am on that. That'd be cool. Really cool.
Sounds
And
perfect.
it does. And it's really funny how, I mean, Marta talked about turbines and turbine coatings. And when you see the career that I'm going to talk to you about, I've spent a lot of time in turbines, but not at that such high temperature in power stations. So so it is funny sometimes how careers overlap, and there's some common themes, even though you come from a different background, etc. So so first of all, thanks for the invite. Absolute privilege to come and talk to you guys. I'm not going to talk anything technical. I've taken the easy way out. I'm just going to talk to you about career, and I am going to talk to you at the end. I've got a slide on leadership skills. And at some point, if you want me to come back and talk to you a bit about some leadership characteristics, I'm very welcome to do that, because generally that's what I talk about these days, as opposed to the technical side of things. So so basically, I'm going to talk to you a little bit about my career, and feel free to question my decisions later on. But first of all, so I started off, unfortunately, I am not an electrical engineer or a control engineer. I am actually a chemical engineer. So I did chemical engineering at Loughborough. I wasn't exceptionally clever. I partied with the best of them, and I came out with a 2-1. So I did chemical engineering from 1990 to 94. But during that period, I was actually sponsored by a company called British Steel. So whilst I was doing my degree, they paid me some money for basically my books, which actually went on beer and gin generally. But they also, one of the beauties of it, it was a sandwich course. So I did my year out at British Steel, but I also did my summers there. So by the time I graduated, I'd had a bit of an experience both on site and on plant. So when I graduated, the deal was if they liked me, they'd offer me a job. And if they didn't like me, they wouldn't. And we'd just walk away and part. But luckily, they offered me a job. But one of the problems that they had, because I was a chemical engineer, they actually had not recruited chemical engineers before. They normally recruited mechanical and electrical engineers just because of the nature of the work. But metallurgy degrees in the 1990s were going out of fashion. So material scientists were really, not many people were doing those degrees. And they thought a chemical engineer would be able to cover the gap in material scientists. So, so I started straight from university. And literally within 6 weeks of starting the graduate program, I get a phone call saying, we've just refurbished 2 electrostatic precipitators. The emissions are worse than they were before we refurbished them. We think it's a chemical problem. Can you come and have a look, and can you come and fix it? So, so I was given the role to try and understand why the emissions were worse than they were previously. So I spent probably 6 to 9 months going inside the precipitator every time the plant was off, scraping the plates, just generally in a horrible, dirty atmosphere, as you can see, and just looking and seeing what was going on. And luckily, I did solve the problem. I worked out what it was, and that gave me a bit of kudos within the company, but also allowed me to go and talk about it. So I would go to the IET and some of the other institutes and talk about some of the issues that we saw there. So I started to get my name known. So I did that job. And then I thought, actually, I don't really want to be a technical engineer. I am a problem solver, but I like dealing with people. So I thought, well, I really want to be a leader. I really want to, well, at first I said I want to be a manager, because at the time I didn't know the difference between a manager and a leader. And I said, I really, really want to manage people. And bearing in mind, those people were men, because when I started that job, there was 4 women in 4,500 men. So very, very few women about, and I just really liked dealing with people. So I said, right, I want to become a leader. So to this day, I really don't know how I had the gumption to do it, but further down the road from that plant that you saw me, there was a plant called blast furnace, and that basically produced liquid iron, and it was an exciting environment. You can see the picture in the top right. It was like that. Every 20 minutes we would pour and cast out the furnace, and there were sparks everywhere, and it was just amazing. And I thought, I really want to go and work on there. So I went and knocked on the plant manager's door and said to him, I love you, this is really sad as well, I love your plant, I really want to come and work on it. It was, at the time, it was the second largest in the world, and I would really come and want to work, and I really want to work on that bit. And in fairness, the plant manager said to me, well, we'll put you in the technical department for 6 months. I want you to understand everything inside and out, and then I'll see if you can do the job. And in fairness, he did. He took a punt on me, and he put me in that role. And I was the first person, at the time I didn't know this, but since then I was the first person in the world, the first female in the world to ever do this role. And it was a really hard job. The guys were, you know, quite old. They were quite vociferous. They didn't believe a woman should be on the cast house. And I remember my first day, I walked out on the job in my heavy metal gear. You can see their woolen overalls. I had a gold visor on my hat, and I walked in, and they all said to me, you can't be a cast house man unless you have these. And they all lifted their t-shirts up, and they were all burnt. And I just turned to them and said, well, I'm not showing you mine, and walked off. And actually, it was a really hard job. And it was, the men were, you know, all credit to them. It was just a harsh environment. The liquid iron was coming out at 1700 degrees C. At the time, we only had metal plates over the runners, so you'd have to skip over them. And for a long time, I had to try and demonstrate that I could live in this environment. And basically, I had a guy who worked for me who wouldn't talk to me at all. He would do his job when I instructed him, but he wouldn't talk to me because he didn't believe I should be there. And then Bob the Gob, who is the guy you see in the picture, was actually a really hard guy to crack. But one day, one of his guys off his team was in a bobcat, and liquid iron flowed all the way around the bobcat and set the tires alight. And he couldn't get out, this guy, and I was the closest to him. So I just ran up to him, grabbed him, managed to pull him out, and my boots set alight. Luckily, we wore quick release boots, because when they did set alight, you needed to get rid of them. So I just flung them off. And after that, I was the best thing since sliced bread. So I kind of won them over. But that kind of, if that incident hadn't happened, that job was very, very difficult. So I did that role. I loved it, but it was hard going. So then I decided, okay, I've done that job for a bit. And actually, they then said to me, well, you need to do a bit more technical stuff. You need to kind of understand the technical. So the plant where I fixed the problem with the electrostatic precipitator, they gave me the plant as the technical manager. And they said to me, we really need to automate this. We need to take some men out. So effectively, we want to take a couple of guys off each shift if you can automate this plant. So I was going there to not only understand how the plant operated, but was going there to automate it and basically reduce the headcount. So as you can imagine, I couldn't tell the people that's what I was doing, but ultimately in the back of my head, I knew that's what the goal was. So I spent about a year looking at the plant, working out, managed to automate it. Actually, interestingly enough, the guys didn't lose their job, they just went elsewhere. But again, I had to talk to the operators all the time. I had to work out how the plant was operating. And one thing I did learn is the plant guys knew their plant inside and out and understood it. But what they couldn't do was articulate the problem. So therefore, things were not solved. So just by listening to the guys, understanding it, and then working out how to resolve it, absolutely, that's basically been my job for the last 25, nearly 30 years. So by listening closely to the guys, that's basically how I managed to solve that. So I was working on that plant. At the time, British Steel, who I was working for, was starting to restructure. I'd had the nod that I was going to be my first middle management position. And then a job came up on the board in the local, on the local job board for the company. And it was a job in America. And do you know what? I thought, I really, really fancy this. So I applied for this job and I had an interview. I hadn't told my boss that I got an interview. And I went and did a video conference interview because it was the first time I'd ever used video conferencing. And I got the job. But they said to me, you need to be out within 6 days. You need to be in America in 6 days' time. So I went to see my boss and said, I've just applied for this job. They've just given me it. Can I go? And he frog marched me to the works manager. And the works manager said to me, if you take this job, Jane, you're either going to sink or swim. And I think you're going to sink. And by the way, if you go, you will never, ever come back to this site. Now, bearing in mind, the site was in Teesside and that was my home. It was like, oh my God, you know, what if it doesn't go right, etc., etc. But then I thought that was really wrong of him to say that to me, because at the time I was 26, 27-year-old. And I thought, you know, but it made me more stubborn. So I thought, sod it. So I went. So I got on a train, went down to Heathrow, flew to America, got a hire car, went to the site. And in fact, I lived there. I lived on that site for 2.5 years. So my job there was quite interesting because this plant had been built in Hunterston, Scotland in the 1970s. It had never been started. And we'd chopped it up into 28,000 pieces, shipped it across the Atlantic, rebuilt it in Mobile, Alabama. My job was to commission the first module, and then the second module I had to finish the build off. But because that plant was 20-year-old, a lot of the equipment manufacturers had gone bust, just didn't exist. And we had all of this equipment, we needed to get it running. The same time I needed to recruit people. I was in charge of the safety and operations. And one of the biggest issues that we had was actually the wildlife. So this plant had a massive gas reformer on the back. So it was quite dark, really, really warm, humid. Bearing in mind, Alabama was 40 degrees heat and 100% humidity. So it was really, really high humidity anyway. So we had black widow spiders. We had a gator, an alligator right at the docks. They gave me a spade when I first arrived and said, that's for killing the snakes. That if any of our operators get bitten, you need to kill the snake, take the snake to the hospital with our operator so that you can get them on our company insurance to get them looked after and tell them what anti-venom to use. So it was a completely different environment and I absolutely loved it. However, I probably worked 20 hours a day for months and months and months to get this plant running. And every time something broke, we had to strip it down to its bare elements and build it back up. And then the final thing with this plant that was interesting is it was prone to hurricanes. So when I first arrived, I got told you have to write the hurricane procedure, the hurricane evacuation procedure. I didn't have a blinking clue. So I wrote something, literally just wrote something. Anyway, one day we did have to evacuate and that was really, really scary. It did quite a lot of damage to the plant. And because it was a huge user of natural gas, we had to keep 2 people there during the hurricane. And our insurance didn't cover those 2 people. And that was a really difficult conversation. We sat around the morning meeting and asked for volunteers. And I volunteered to stay and they wouldn't let me because they said if I got into trouble, I didn't have the strength to get out. And that was just an awful, so 2 people volunteered, but I volunteered to go and sit with their families whilst the plant was subjected to hurricane damage. So that was really, really interesting. But then there was a problem in one of the other plants in northern Alabama in Forrest Gump country, and I got asked to go and solve this problem. Basically, they had 40-ton steel slabs. And those steel slabs were coming off the mill and they had pinhole bubbles in them. And if you can imagine, you're rolling a slab, it's a bit like dough. You roll the slab with the bubble in and the bubble elongates and becomes a crack. And this steel was going into the oil and gas sector as pipelines. And they were having 50% rejection rates. So they said, we're desperate for somebody to solve it. It's been a problem for 9 years. We've had all these clever people here, Jane, but can you go up and have a look? So I spent 9 months at that plant, managed to solve that problem, and then they gave me the plant to run. So I ran that plant as well for a couple of years, but that was in Tornado Alley. So we had to deal with tornadoes, where tornadoes, you get 15 minutes warning before they drop out the sky. That's if you're lucky. And they are really serious events. So we had to, a few times we've had to evacuate, and then sometimes we just had to keep the plant going because we didn't have enough notice. So that was quite scary as well. But after the last tornado, at the time I was doing my MBA back in Warwick, and every 6 weeks I was flying back to the UK for lectures on a weekend. I remember at 4 a.m. sat in my little tornado shelter in my apartment, which was in the garage, thinking there's more to life than this. I want to go home. So I went home. So I did that for a few years, and then I went back to British Steel, where I came back as a senior manager and ran 2 of their coke ovens, which are sort of big assets, as you can see, 250 men, 2 plants, and did that for a couple of years. And then I decided the steel industry was going south, and I really needed to get out. And also I was getting to the point where I was known for iron and steel, and I needed to make sure my career diversified. So luckily I was headhunted by a company called Semcorp, which were effectively a power company. It was based in the northeast of England, and their main raison d'etre was to make steam for petrochemical plants, and electricity was a byproduct. And I went to run 2 coal boilers. Unbeknown to me, when I started, the coal boilers were absolutely shot. Availability was rubbish, and my job was really to get the availability up, but also to look at the future of steam generation on that site, because it was critical. So I managed a couple of coal boilers. Then during my tenure there, which was about 9 years, we built 2 gas turbines, and then we built the UK's first biomass power station. So we built the power station. It used recycled wood and what we call virgin wood, which is basically logs. I think we were very, very naive when we started it up, because we all thought wood was wood. But actually, wherever a tree grows, it picks up the nutrients, and those nutrients sometimes are not good for the environment. So if you cut down a forest near the seaside, it's bound to have a lot more chlorine in, etc., etc. So for the start, for that plant, when we started operating, it literally was, availability was 68%, and we spent 6 months till we got it up to the high 90s. But that was a really hard slog. So after I'd done that, I thought, I need to start thinking about moving. I'd been there 9 years. Every time I thought of moving, I either had a new asset to build or they gave me more. So I ended up as Senior Vice President of Operations for that group. And then I said, right, it's time to move on. So again, I was headhunted, but I looked at my CV, because I always thought I wanted to be an MD. And when I looked at my CV, there was 2 things missing. One was commercial experience, because generally our contracts were really long or internal. So British Steel, it was a lot of internal contracts. Semcorp, it was external, but there were 10 years, 20 years contracts. So I hadn't done a lot of that. And also, if you look at some job profiles at very senior levels, they manage teams remotely, so all over the world. And I could not demonstrate that. So I thought, what am I going to do? So I got approached by a company called Cape Industrial Services. So that was what I was thinking about. I got approached by a company called Cape Industrial Services. It was a bit wacky. A lot of my friends said to me, what on earth are you doing? And effectively, they did scaffold insulation and painting. So I went over as an ops director for the Northeast region. Within 2 weeks, I got the Northwest region. Unfortunately, I had to sack the general manager, and we had to put some other things in place. So I had to literally drop down a level and really understand the job, which was really good experience. And I did that for a couple of years. And then my MD said to me, we've got some companies that are quite technical. They were bought 7 or 8 years ago, brought under the Cape banner, but they've never been merged into the Cape brand. So can you look after those businesses? Can you manage those businesses? Can you become the statutory director for those businesses? And can you grow them? So I took those on. Effectively, there was 3 businesses. There was a company called Motherwell Bridge, which builds gas holders, tanks, heat exchangers around the globe. A company called York Linings, again, a global company that does refractory. And then a company which was pretty UK based, but was environmental services, so chemical cleaning, so sort of really funky cleaning techniques. And I did that for, again, a couple of years. brought them in under the Cape banner and grew them. So globally, we grew quite a bit. And I really enjoyed that because that was getting back to my technical roots in effect. So I did that for a couple of years, and then a company called Altrad bought us. And at the time, Altrad wanted to get their brand known in the UK. So I volunteered to do a job called the Transformation Director's role. Effectively, what that was to do was to take 3 companies, Cape Hotel and a company called NSG, merge them into one within a year, get a brand known, get a brand out there, but also merge things like procedures, legal entities, you know, all of those kind of things that we use on an everyday basis, and merge those 3 companies and become the UK's largest industrial provider at £600 million a year turnover. So that was my job. Also, I had to reduce headcount, so I was a little bit of a hatchet woman. So we had to, you know, where we brought together financial teams, we only needed 1 financial team, HR, etc. Luckily, there wasn't an overlap in operations, so there wasn't a lot of headcount to do there. So that's the job I did. But when I finished that, I thought it's now time to move, because I'd done most of the things within that business. And my ex-boss called me and said, how about you come to Bilfinger? And that was the natural move, because Bilfinger was a competitor of Altrad, but actually Bilfinger was more engineering biased. So today my role is running engineering design, automation business, a panel shop, a couple of fabrication shops, and also the major projects division in the UK for Bilfinger. So that's what I do today. So effectively I've gone back to my technical roots. So that's really my career. I don't know what's next, but what I will say, just a couple of things that I think for me have been my success. And I just really wanted to share, because I think some of these are quite useful. I think no matter what you do or where you are, you've got to know your stuff, because that is fundamental to you being successful in your career. So you've got to understand your topic and know your stuff. I think you have to earn your stripes, especially if you're from a diversity perspective, if you're one of few. People generally know your name, which is a good thing, but also people are watching you, so that when you mess up, they also know when you mess up. So earning your stripes is quite important. You know, being in the thick of it, listening, understanding, etc. That has actually worked really, really well for me. When you do go into a managerial role, some of you will be in there. You're only as good as the team you've got. If you've got people who are not very good, deal with it. If you don't deal with it, they only bring the team down, and your team know you're not dealing with it. So it's quite difficult, but you really do have to create a good team, because if they're successful, you're successful. Make a decision, don't dither. If you're in operations, you've got to do that anyway. If the phone rings at 3 a.m. and the boiler's tripped and they're asking you how to get it back on, you've got to make a decision, but make a decision, don't dither. But also be okay with yourself for saying I made the wrong decision, and say sorry, because I think that goes a long way to earning your stripes as well. I seek out other leaders, ask people to be your mentors. Nobody's going to say no generally if you're going to ask them to be your mentor. In fact, they'll be flattered. I always think if I look around, I need to be inspired by people. And if I see somebody that's really good, I want to try and copy that trait. So seek out your leaders. Stand by your convictions. If you really think you're right, demonstrate it and stand by it. Don't be bowled over. If somebody else is noisier in the room and you really think and know you're right, get your point across. Stay calm and carry on. That is really, really a good phrase. When things get difficult, stay calm. Everybody, from your MD, your CEO, gets stressed. Everybody gets stressed. It's how you deal with it that's important. So stay calm, look after yourself and your mental health, and bottom line is have fun. So that's my career. I don't know what it's going to be for another 10 years, but hopefully it's of use and interesting to you guys. Thank you.
Thank you very much for that, Jane. That was incredible and a very vast experience you've got there. Is someone's already started off with the questions?
No.
What would you say is the biggest obstacle you faced as a woman in this field?
so the biggest obstacle really is the discrimination piece. Because when I started, like I said, there was 4 out of 4,500 people. And people didn't know how to deal with me. They didn't, you know, they didn't understand. And I was a real novelty. And what I realized, and sometimes people just really didn't speak to me. I know I talked about that guy that was extreme, but some people, and what I realized was, because I was a novelty in the workplace, some people didn't know how to speak to women. And I was, you know, and so actually just listening, being patient, being interested. I mean, I hate football, but I still watched the game yesterday because you want to be able to interact with people. So, the biggest thing really is about people being discriminatory, but also when I started work, the workplace was discriminatory. There was no ladies' toilets. I got changed in the cleaner's cupboard. I used to have to go to the men's toilets and sing really loudly when I was in the cubicle. You know, and even today, all of us, especially all the females, overalls are not designed for women. You know, and you have to modify them. I mean, I've still stitched my cuffs of my overalls that I wear today because they're just too long for me. So just being adaptable, just understanding, just being in the position, if you're somebody that's not used to dealing with females, just make it easy for them. That's the key thing.
Yeah. I think that's just so common in general anyway. As someone else who's like starting off their career in a big firm, it's incredible how much you don't realise, and how certain people, especially when you go on site, can obviously have that impact of, oh wait, you're telling me this. They do react still to this day, and it's insane. But yeah, there we go.
Sorry, Georgina, the one thing I will say is, if it is extreme, just remember it's their problem and not yours.
Yeah,
don't let it affect you.
No, it's always yeah, you've got to keep that openness, haven't you?
Yeah.
Another question here, can you describe what caused the air bubble problem and how you managed to fix it?
Yeah, in very simple terms, it was nitrogen getting into the liquid iron before it went in to cool. So what they used to do is, you've probably seen pictures of it. Basically, you get a big vat of iron, or steel in this case, because it was the steel mill. So a big vat of steel, and it goes through a ceramic shroud. So it's basically a ceramic sausage in effect. And it goes into what we call caster blocks. So it goes into a block, and then that gets pulled through to a furnace. And what was happening in the shroud, it's really basic when you think about it. What was happening in the shroud was air was getting in, and the bubbles were nitrogen. So the shroud, in effect, the shrouding wasn't good enough. So effectively, we had to try and cast it under a vacuum, try and stop air getting in. So we did lots of things by changing the type of the shroud that we used, how the airflow was around the area. I mean, initially we thought it was when it was cooling, the bubbles were coming, but actually it was all about air ingress at the start.
Right, okay, interesting. A different question now. What do you think of the additional schemes or events such as this today, or awards for women to encourage more females into the profession? Do you think it encourages more into the profession?
So it's a difficult one, because sometimes this can be gleaned as positive discrimination. But so a couple of things for me. I think things like this are brilliant, because they're a safe environment. You can ask all the questions, and it doesn't have to be about women, you know, it's about diversity really. So it's not really about women as such. So I think things like this are great. I think awards are good, as you know, usually you find in an award ceremony there might only be one award for women. I think there needs to be more role models out there for engineering, so youngsters can see it. So I agree with awards. But we need to market out there, you know, some of you guys that are on this call, absolute brilliant role models for youngsters. I'm too old these days, but you guys, absolutely brilliant. So showing people that you can look like a girl, act like a girl, and be, you know, be an engineer is absolutely brilliant. I mean, I usually go into schools these days and say to, particularly because I sometimes go in all girls schools, you know, we actually, you're going to kill me now, chemical engineers were second in the graduate salary. You know, dentists were first, then chemical engineers, and then doctors. And, you know, and they're, oh, no. And I said, you could have a Prada handbag, you can do whatever, you can earn your own money, and you can travel the world. Who doesn't want to be an engineer? And everything you touch today, everything you've got on is being handled by an engineer. And just getting that enthusiasm. So I agree with all of the positive role models, awards, etc. I don't believe in quotas. That's the one thing I don't believe in. So I think I've seen too many women in particular fast-tracked in their career, and they've not had a support mechanism, and they've failed, and it's really knocked their confidence. So, you know, I think you got to be careful with that.
Yeah, I think it can. Obviously, you see a lot in there is the IET magazines and things. It's a lot about percentages, isn't it, of how many females have been employed this year and things like that. I personally don't think that should be so like vocal about, but as you said, obviously the awards and getting that role model persona out there is incredible, and I think that helps more.
Yeah, absolutely. Well,
yourself with a CBA, is it?
Yes.
Is that right?
Yeah.
That's an incredible achievement yourself. You didn't mention it in your presentation much, but that must have been, you know, such an incredible moment.
It was, but I also sound boring because it was a CBE for services to chemical engineering, so I don't like to say that bit.
It's still an award though, isn't it, like you just said, and it's such an achievement to get noticed for that, so congratulations on that as well.
Thank you very much.
Couple more questions here. What would be your best one-liner in response to a negative attitude and comment from a male colleague like that?
I'm going to struggle with that. I am quite quick off the mark, I have to say, and I can swear with the best of them. Generally, I will say to you, I do revert to being technical. So if somebody makes me a one-liner comment about being a female, you know, I go back and say, you know, well, you know, I'm an engineer. What, you know, I'll just go back and say, I might look like a female, but I'm a better engineer than you are, I bet you. So, you know, just being quick off the mark and just being flippant and just walking away, really. Yeah.
Completely. Another one, Jane, over your career, have you seen any significant changes in accepting women in engineering?
I think there is more women, it's more visible. I don't think there's been a lot of changes, if I'm being honest. I actually think COVID has expedited a change for flexible working for particularly women. One of the things, I mean, I don't have children myself, and I don't think I could have had my career if I had children at the time. I think these days, flexible working is a huge benefit for women. And the other thing that's very, very sad, in my opinion, is a lot of very good female engineers go off and have their children and then struggle to get back into the sector. And we've got to help those women who are trained, competent engineers to be able to get back. And we should support them. So I haven't seen a lot of changes, if I'm being honest. But I think it's coming. I think it's coming quick, which is great.
It's good to know. That's all I've got through. Oh wait, I say it and then someone else asks a question. Did you notice any difference in the attitudes between the UK and the US?
Yes, I was extremely naive. I thought because we spoke the same language, I thought we were the same. Now, bearing in mind, I was in the deep south. What was interesting was when we were constructing the plant, there was a lot of female in construction. You see a lot of women in construction in the US. There's not many women in the operations or engineering side, but in actual civil construction, there is a lot. So that surprised me.
Oh, wow.
I was in the deep south. The segregation of black versus white was horrendous. I had a maintenance manager who worked for me, and he was in the KKK, and he refused to talk to any of my black operators. And it was awful. And you know, when you come from the UK, you don't you don't actually look at colour. You just didn't look at colour. You just look. They were, you know, for me, they were the operating team, and I remember getting a lot of flack for some of the operators, and it was like, no, they're good at the job. They know, you know, those guys know what they're doing. Stop it. And that was really difficult to deal with. And that was the biggest change. Yeah, and also they all think we know the Queen. So the amount of times I get asking the question, do you know the Queen? It's just so backward in that respect.
Yeah. Just to expand on that, did that obviously impact you staying over there for longer, or, you know, obviously the difference in how the attitude was? Were you scared, not scared almost, but, you know, did that hinder you staying there for longer than you'd anticipated?
Not really. I was at a crux where I got asked, did I want my green card or did I want to go home? So I had to make a decision because I was on a visa at the time. I mean, I was single when I was out there, and what I realized was a lot of, in the deep south, they don't travel. So loads of people, they'd never been to Europe, they'd never been, and I missed culture. I used to get the newspaper sent to me every week from the UK. So I missed all that. And that was the reason why I went home. But I loved, I mean, I had the time of my life, you know. I was the first UK person in a Mardi Gras association, and I partied with the best of them. And I've still got friends
sounds
there
wonderful
now.
In this day and age, doesn't it?
Yeah, definitely.
Brilliant. Another question here. Promoting women in engineering is important on every level, but how do you think engineers can achieve a greater status in the UK? So
this is a debate we've had as a professional engineering institution group, so the IET, the IMEC, etc., because we've had a whole discussion several times about chartered engineering and being at the same level as being a doctor, for instance, a medical doctor, and how do we do that? And it's really difficult because the word, and we've struggled because the word engineer is used in a lot of things. I mean, the classic is the gas engineer, which is actually a boiler fitter. And how do you differentiate, you know, a gas engineer at British Gas to an engineer that we are today? And it's really difficult. And I don't, most of it is about educating the public in what we do, because people just don't understand. I bet most of you have said, when somebody has said to you what you do and you say you're an engineer, and they say, well, what actually do you do? They don't understand. So it's getting that education out, and it's you know, it's talking to people about what we do on a daily basis. And I think that will start getting our status up. And I do think, I mean, for me, chartered engineer is the pinnacle of an engineer's career. And that's what, you know, that's what we should be doing. And we should, you know, say anybody who gets chartership should be celebrated. It's a brilliant event. And so that's really, really important for me. And we should sing and shout about it.
Yeah, I couldn't agree more. And someone's also commented as well, and just to round off on what you've just said, if you haven't written a book covering your career to date, please do. And I have to agree with them. It's incredible listening to you.
Well, I've got loads of stories. I've got loads of stories. Yeah, I only told you some of the nice things, but thank you very much. No, it's nice to share it as well, and also if I can help you not walk into the things that I did, then hey, we've succeeded today. So thank you.
No, thank you. Someone now commented telling us a story.
Tell us a story.
Yeah.
Well, when I moved to, I will tell you, when I went to Mobile, I told you that I had a video conference. I'll tell you two stories then quickly. So I had a video conference, and it was the CEO who interviewed me, and he was a Brit. So I came over, I got in a car, went to plant, met the CEO. He introduced me to the plant manager who I was working for. And the plant manager was an Egyptian guy, Hussein. And Hussein thought Jane was a male name. And he saw me, he said, I am not having a woman working for me. And luckily, the CEO was with me. He said, no, this is your ops manager to saying you got to. So for a year and a half, I remember having a massive argument outside the furnace that was off, that I was going in to inspect and he wouldn't let me in because I was a woman. And I used to just ignore him and just get in. So you know, there was lots and lots of not only segregation in the US, but also because the plant had, you know, the operating team was international, I had that. What I will tell you was one of the operators who worked for me, he came into my office and he went, "Ma'am, I've been bitten." And I thought, oh no, the snake thing, I'm going to have to do it. I said, well, where have you been bitten and what is it? He says, a black widow spider ran up my trouser leg and has bit me on my left testicle and it's up like a melon. And I thought, no one's taught me how to deal with this. So I did have to bundle him up and take him to the car to take him to hospital. But he would never look me in the eye after that. He worked for me, he was a great guy, but he wouldn't look me in the eye. I was so embarrassed. So yeah, dealing with the wildlife was interesting.
Yeah, that's the whole different side of it. We don't really have as exciting wildlife in the UK, I guess.
Good thing, believe me.
Oh dear.
Yeah.
I love it. Is there any more questions at all for either Jane or Marta from the group? Other than that, I think Bibek has obviously put the details in the chat for those of you that need the CPD certificates, etc. And obviously all the details there is on the slides, and obviously you can see this webinar on YouTube as well. So it's all there for everyone, and any details or anyone wants to re-listen to the amazing stories that both of them have shared. So thank you very much. And yeah, as someone's just said in the chat, it's a great event and conversation, great stories, and thank you very much. And I completely agree. Thank you very much, both of you, for joining and agreeing to take part in this.
No problem. Thank you for having us. And Marta, all the best.
Yeah, thank you.
You've been safe.
Thanks.
Yes,
definitely. Good luck at when you get there over in
Fingers crossed.
Yeah, definitely.
Thanks, everybody. Have a good night.
Thanks very much, everyone.
Bye bye.
Take care.